Good day everyone, my name is Differential Bucsit, and in this video we're going to talk about partial differential equation. We're going to use Python. Our IDE is Jupyter Notebook. This is a requirement in the numerical solution to CE problems. So let's start. So first things first, we must derive our equation. So, ito yung original equation natin. This is the heat conduction equation for metal rods. This is only one directional. So, it means we're only finding the temperatures in the x-axis. In one axis only, specifically the x-axis. So, partial differential equation is denoted by this, the del symbol. So, partial differential equation siya kasi derive natin siya in terms of dalawang variables. So, first variable nasa left ng equation is in terms of x, its distance. So, kung ito yung rod natin, define natin yung temperature ng nodes based on its position. So, on the right side of the equation, it's time. So, habang tumatagal, iinit ba siya or magiging cool. So, we're deriving this on the right side of the equation in terms of t. So, kaya siya partial differential equation. Kasi meron tayong dalawang variable na kailangan natin i-derive. So, our alpha is equals to k over rho times c. Our k is thermal conductivity, our rho is density, and c is specific heat. So, this part of the equation is this. This is the central divided difference equation. This is the temperature at a given location. So, on the right side of the equation, we have the temperature at a given time t. So, we're going to use this equation. If we combine these two equations, we have this. So, we have our alpha, and then our derivation of t in terms of x, ito. And then, yung sa right side of the equation, ito. So, yan. Yung equation natin. Now, we're going to find this specific variable niya. So, this is the temperature na current. Yung J plus 1 sa taas, denote niya na ito yung current. We're going to find the temperature of the current based on the past. So, yung J, this is the past time. Lahat ng J's na ito. So, we're going to find the current. So, separate natin yan. So, yun na yung ating J plus 1, temperature at present time. Temperature at present time. So, yan. So, para mas masimplihan natin yung equation, palitan natin ito ng lambda. So, yan na yung ating equation. Heat conduction equation for metal rod. So, yan yung gagamitin natin para masolve itong problem. So, ito yung problem natin. So, our problem is a 0.1 meter steel rod with an initial temperature of 0 degrees Celsius is subjected to temperatures of 80 degrees Celsius and 30 degrees Celsius on the left and right end respectively. Use explicit method to determine the temperature distribution at t is equals to 5, x is equals to 0.4 meters, b, t is equals to 10 seconds, x is equals to 0.06 meters, and c, temperatures at t is equals to 15 seconds. So, basically, meron tayong steel rod dito. And then, yung nasa left niya is 80 degrees, yung nasa right niya is 30 degrees, and we're going to find yung temperature distribution niya at 0, at 5, at t is equals to 5 seconds, at time is equals to 5 seconds, and then 10, and then 15. I-find din natin yung temperature niya at a given point dun sa rod. I'll elaborate that later. So, our given here is our thermal conductivity, our density, and our specific heat. Our change of x is 0.02 meters and change of t is equal to 5 meters. So, to elaborate the problem, so ito yung rod natin. Imagine ito yung rod natin. So, it has a length of 0.1 meters. It has a change of x is equal to 0.02 meters. Meron tayong 6 rods dito. 1, 2, 3, 4, 5, 6. And then, with a distance of 0.02 meters between each rods. Each nodes, meron siyang distance 0.02 from each other. Now, based on the problem, meron tayong initial condition na 0 degrees Celsius. And then, we have a boundary condition na 80 degrees Celsius sa left at saka 30 degrees Celsius sa right. So, yan. So, our initial condition states that itong rod natin, so itong nodes na ito sa gitna, is 0 degrees Celsius. So, those are our conditions. So, yan. Yung initial temperature natin yan. So, T is equals to 80, 0, 0, 0, 0, and 30 degrees Celsius. So, we're going to find what is the temperature gradient for T is equals to 5, T is equals to 10, T is equals to 15. This is time. We're going to find the temperature at this time, 5 seconds, 10 seconds, and 15 seconds. And also, we're going to find the temperature at each of these nodes in each of this time. So, yun yung problem natin. So, let's start coding. So, dito na yung Jupyter Notebook natin. So, nilagay ko dito yung ating equation, yung problem, saka yung figure. So, let's start coding. So, first things first, lagay muna natin yung libraries na kailangan natin. So, we have NumPy. We're going to use NumPy here as NP. Also, we're going to use matplotlib. So, from matplotlib, import pyplot as plt. So, meron tayong as para mapaldalian lang tayo mag-coding mamaya. Shortcut lang siya, yung mga as na yan, np at saka plt. So, let's state our constants. So, define our constants. So, problem na ito, 0.1 meter yung length ng steel rod natin. So, lagay natin dito lahat ng constants natin. So, L is equal to 0.1 meters. Next, we have our dx. Yung change of x natin, 0.02 meters. Yung distance ng each node to from each other. So, and we have our nx, our step, distance step. Now, this is an integer para mas baka mamaya si Python float yung masagot niya, kaya maglagay ako ng integer dito. Kasi magdi-divide tayo ng L divided by dx para makuha natin kung ilang nodes plus 1. Now, why plus 1? Kasi kapag i-divide natin ito yung length natin, divide natin siya by dx, makukuha lamang natin itong unang space na ito, tsaka ito. So, 5 lamang siya. Kapag hinati natin itong length na to ng 0.02. 5 lamang siya. Meron tayong 6 nodes dito na kailangan hanapin yung temperature niya. So, kaya may plus 1 tayo dito. Then next, we have our final time, TF. So, 15 seconds ilagay natin dito. Now, dito sa problem, hanapin natin yung time natin at 5, 10, 15. So, for now, our time is 15 seconds para mas mapadalan tayo. So, our dt is 5 kasi 5, 10, 15. 5 yung difference nila. And then, our time step. Time step is integer tf over dt plus 2. Y plus 2. Kasi kapag i-divide natin yung TF natin by dt, meron tayong 3, pero nag-start tayo sa 5. So, plus 2 tayo para maging 5 na siya. Then, next, we have our constants. K, thermal conductivity, which is 54. Then, we have our rho, our density, which is 7,800. Then, we have C, our specific heat. This is 490. So, given lahat yan dito. Yan. And then, we have our alpha. Alpha. Now, given dito, yung alpha natin is equals to K over rho times C. So, this is equals to K over rho times C. And then, we have our lambda. Our lambda is equals to, makita natin dito, alpha times change of t over change of x squared. So, that is alpha times dt. dt over dx raised to 2. So, yan. And then, we have our initial temperature. Now, initial temperature ng rod is, of course, according to the given, is 0 degrees Celsius. So now, we have to define our x. We have to define the lengths ng x natin. So this is np.linspace. So these are arguments. So magsisimula tayo sa 0 kasi yung rod, magsimula tayo sa 0, which is, kung ipa-plot natin yung rod natin, 0 hanggang sa length niya. So this is 0, yung unang argument natin, hanggang sa L, which is yung length niya. Tapos meron tayong nx, which is yung step ng bawat nodes. And then, we have to define our temperature. This is our result parameter. So, T is equals to NP that once nx times yung ating initial temperature. So, yung sinasabi nito is yung temperature at a given node times yung initial na temperature niya. So, now we have to solve our equation. So, we have to input this equation dito sa Python. So, we're going to have a for loop here. So, for j in range 1, 2, and t. So, itong for loop na ito, yung ginagawa niya is, naglo-loop siya. Nagsimula siya sa 1 hanggang sa nt. Yung time step natin. So, for j in range, so we have our tn is equals to t dot copy. Now, so yung tn natin dito, this is the previous temperature ng rod. Yung previous temperature natin sa una is yung ating initial temperature, which is 0 plus yun sa side niya is yung ating boundary conditions. Now, so, ilagay na natin yung ating equation. So, T so, yan. Nalagay na natin sa code yung ating equation. So, bakit ganito yung itsura ng ating code? So, may logic kasi si Python eh. So, ito yung kanyang logic. So, ito yung equation natin sa baba. Yan yung ating equation. Now, Dito sa equation natin, meron tayong I. This is the position. Yung I is nag-denote siya sa position niya sa ating rod. Samantalang yung J, nagde-denote siya ng ating time. So, meron tayong I plus 1, I minus 1, tsaka I. So, yung TI natin is, yun yung hinahanap natin. So, for example, ito yung TI natin. Ang ang equation natin na ito, nagbe-base siya dun sa kanyang adjacent na nodes. So, itong sagot na ito dito sa TI, nagbabase siya sa adjacent nodes niya. Maging TI siya kapag meron siyang katabi na dalawa. Meron siyang adjacent na mga nodes. So, TI can only take these values dito sa gitna. Kasi, itong mga nakabilog na ito, meron silang adjacent. Yung TI plus 1, yung nasa right side naman siya ng TI. So, it can take the values of T2, T minus 2, T minus 1, tsaka yung wala. Yung Python kasi, ganito yung kanyang logic. Nagsisimula siya sa 0, then 1, 2, tapos, kapag na-reach na yung gitna, magiging negative 2, negative 1, nagde-decrease na siya hanggang sa wala na. So, ganun yung meaning niya. And then, lastly, we have our TI minus 1. Yung TI minus 1 is yung nasa left ng TI natin. So, it can take the values of T0 hanggang TI minus 2. So, sulat ko dito, TI can take the values of T of 1 colon hanggang negative 1. So, TI plus 1 can take the values of 2 hanggang sa wala. Ito. And then, lastly, TI minus 1 can take the values of T0 hanggang negative 2. So, hence, ganito yung itsura ng ating coding dito. Now, kung titingnan nyo dito, T1 colon negative 1. So, ito yung TI natin at the current time. Yung TN kasi dito, nagde-denote siya ng previous time, yung initial time natin. So, yung current, yung temperature at current time is equals to datas ng previous time. Temperature ng previous time, which is ito, naka-highlight. So, ito yung TI plus lambda, TI plus 1 minus 2 times TI plus TI minus 1. So, yan. Now, define na natin yung ating equation. I-define naman natin yung kanyang boundary conditions. Now, kung makita mo dito, yung T0 natin, this is 80 degrees Celsius, which is given na dun sa ating problem. So, T0 is equals to 80. Samantalang yung nasa kanyang right, is 30. So, yan yung ating boundary conditions. So, yan. Natapos na natin yung ating for loop. Now, so, paano natin mabivisualize ito? No, kailangan natin i-plot. Kaya natin i-find yung sagot, di ba? So, yan, para maganda yung ating pagka-print. Yan. So, values x and t at t. And then, print x and t. Meron na tayong sagot dito. So, dito, ito yung ating x. Ito naman yung ating temperature at that location. So, our t is equals to 15 seconds. Currently, nandito tayo sa t is equals to 15 seconds. Now, para mas madalian tayo ma-interpret ito, yung data na ito, i-plot natin siya. So let's plot our graph. So we have plt.figure fig size. So define natin yung size ng ating graph. So 4, 4 para malaki-laki, dpi is equals to 100 para pwede natin ma-download siya as high resolution, di ba? So next, plt, plot na natin yung ating x and t. And then plot natin yung axis, yung hangganan ng axis natin. So yung ating arguments is 0 to L. Yun yung ating x, yung sa x-axis natin yan. So sa y-axis naman natin, ito naman yung kanyang temperature, which is 0 hanggang 80, di ba? So for the sake of, para mas maganda siya tingnan, lagyan natin ng 90. Yung maximum kasi natin na temperature, di ba, 80. Lagyan natin ng 90 para hindi naman sagad dun sa graph yung ating graph, di ba? And then we define our x-axis, x label. So this is the distance in meter. Wait. Plot.y label. Define na naman natin to. PLT. Now, so this is our y label is the temperature in Celsius. And then next, we show our graph. plt.show. Whoops. Error. So, yan. Tapos na natin yung ating codes. So, tingnan natin. Press natin yung Shift Enter para makita natin yung graph. So, yan na yung ating graph. Kung makikita natin, ito yung ating distance. Yung x-axis natin, 0 to 0.1. Yan yung length ng ating rod. And then dito sa y-axis natin, yan yung temperature. Ranging from 0 to 80 kasi yung nasa left niya is 80 degrees Celsius, yung nasa right niya is 30 degrees Celsius. So, yan yung gradient. That is this is the temperature distribution at time is equals to 15 seconds. So, for its values, ito yung ating x-axis, ito yung 0, 0.2, 0.04, so on and so forth. And then, dito, ito naman, is our time. I mean, our temperature. Ito naman yung ating temperature, which is 80, ito, 29, 5, 2, 11, and then 30, back to 30. So, yan. Meron na tayo, na-plot na natin yung ating So, yan, na-plot na natin, di ba? So, try natin siya in its initial. So, palitan natin yung ating TF to 0. So, yan. At time is equals to 0, kung makita natin dito, 0 degrees Celsius yung ating inner nodes. Samantalang yung ating boundary is at boundary condition pa rin, 80 degrees Celsius tsaka 30 degrees Celsius. So, paano natin ma-prove na tama itong coding natin? So, check natin kung tama itong ating code, di ba? So, check natin. mano-manong check. So, ito yung ating equation. Then, dito sa right side, na-define na natin dito yung ating constants. So, ang alpha, combine natin yung alpha, lagay natin dito. So, lambda is equals to, yan. Ito na yung ating equation. Pag kinombine tong dalawang equation na ito. So, salpak natin yung mga, itong mga constants dito. So, yan, kapag i-equate natin yan, our lambda is equal to 0.1766. So, meron na tayong lambda. So, yan yung ating figure. So, at time is equals to 0, this is our initial time. Meron tayong boundary condition na 80 degrees, tsaka 30 degrees, and then the rest is 0 degrees Celsius. That's our initial condition. So, hanapin natin yung temperature niya at T is equals to 5 using this equation. So, again, our boundary condition, di yan nagbabago. 80 degrees Celsius siya at dito. And then, dito naman sa next na node, salpak natin yung ating equation. So, T01 is 0. T01 ito. So, 0 plus lambda. Lambda ito. T02 is 0. Minus 2, T01, minus 2 times 0, plus T00, which is yung 80. Ito. That is equals to 14.128 degrees Celsius. So, that is for our, this node. So, for the next node naman, for the rest of the node, so yan, hindi natin pahabain ito. Papakita ko na lang sa inyo to kung paano na-solve yung mga yan. So, the next node is 0 degrees Celsius, the next is 0 degrees Celsius, the next is 5.298 degrees Celsius, at time is equals to 5. Now, check natin kung tama nga yung na-solve natin. So, tama nga ba na 80, 14, 0, 0, 5? Yan natin. So, that is at time 5. Palitan natin yung ating final time to 5. So, 80, 14, 0, 0, 5, and 30. So, tama, di ba? Same sila. Now, let's try at time is equals to 10. So, yan. Using our previous data dito. So, yun nga. T02, boundary condition, 80 degrees Celsius. Ngayon, find natin tong node na ito. So, T11 is equals to 14.128, and then lambda, ito. T12 is 0 degrees Celsius, ito. And then T11, ito. And then T10, this is 80. So, salpak natin dito sa equation na ito. Kuha natin yung sagot na 23.2660 degrees Celsius. So, the rest of the nodes dito, so yan yung sagot nila. So, 2.4950, 0.9356, 8.7247, and 30. So, tama nga ba yung ating sagot? Same nga ba? So, 80, 23, 208. So, try natin 10 dito. So, 80, 23, 208, 30. So, same, di ba? So, that means, tama yung ating coding. Tama yung ating pag-code compared sa mano-mano, di ba? So, we can say that tumpak ito. This is accurate. Now, so, sagutan na natin yung ating problem. So, yung ating problem sa A, at t is equals to 5 seconds, x is equals to 0.04 meters. So, salpak natin yung 5 seconds, t is equals to 5 seconds, change natin itong tf into 5. And then, hanapin natin yung distance niya at 0.06. At 0.04. So, ito. So, at 0.04, so 1, 2, 3, 1, 2, 3, 0 siya. 0 yung ating temperature at that point. So, dito, makita natin 0 pa, di ba? So, yung sagot natin dito is 0 degrees Celsius. So, next, at t is equals to 10 seconds, yung time natin is 10 seconds. So, ano nga ba yung kanyang temperature at 0.06? So, at x is equals to 0.6, this is 1, 2, 3, and 4. Pang 4 siya. So, 1, 2, 3, and 4. So, ang sagot natin dito, ang temperature niya at t is equals to 0.6, kung makita natin dito sa graph, yung 0.06 is 0.93, di ba? Parang kunting alis lang dun sa 0. So, 0.94. So, this is 0.94 degrees Celsius. Yung temperature natin dyan. And then, hanapin naman daw natin yung temperature lahat ng nodes at temperature at time is equals to 15 seconds. So, palitan natin tong ating final time into 15. Then, we have this. So, ito na yung ating temperatures at each of these nodes. So, yan na yung ating temperatures at t is equals to 15 seconds. Makikita natin dito sa graph. So, naka-align naman yan. 29 ito, yung 0.02, yung 0.04 is around 5, and 0.06 is around 2, 0.08 is around 11, and then 30 dito. So, bago tayo magtapos, i-show ko muna sa inyo yung kanyang paano nga ba nag-work itong temperature distribution. So, i-zero muna natin itong TF. So, at time is equals to 0, kung tingnan natin dito, yung meron lamang mataas na temperature is yung ating boundary conditions. Samantalang hindi pa nagbago yung ating inner nodes. So, at time is equals to 15, umiinit na yung inner nodes, di ba? So, tumataas na ito. So, try natin at 1 minute, that is 60 seconds. So, tumataas na yung temperature, di ba? And then, try natin 1 hour. So, kung titingnan natin dito, yung ating graph, it approaches these values, itong temperatures na ito. So, from 0, magsimula tayo sa initial temperature na 0, nag-increase siya hanggang ma-find niya itong straight line na ito, in which from 80 to 30, it approaches these values, 80, 70, 60, 50, 40, and 30. So, yan. In the end, yan yung makuha niya. Kapag increase pa natin yung time dito, yan din yung ating mahanap. Kasi yun yung kanyang talagang distribution ng temperatures. Diba? In the end. At yun, dito nagtatapos ang ating video. Again, I am Stephen Bucsit, and I'm out.